All right, hello everyone. So today we're looking at it's a continuation of a problem we had. We're trying to find the interval of convergence of the series n times x minus 4 to the n over 2 to the n. So when you're asked for the interval convergence, the first thing you want to work with is finding the radius of convergence. And let me just step back for a second and take a look of how you go about doing that. So when you're looking for the radius of convergence, you're going to use a test. It could be the ratio test, the root test, geometric series. It all depends what's given to you. In our case, I'm going to use the ratio test because you have it's easier to apply. In particular, I see like an exponent term with the 2 to the n. So that's what makes me want to use the ratio test. If I had just exponents, sort of like 1/3 to the n, something like that, x minus 4 to the n, then maybe I'd consider using a root test or a geometric series of tests as well. Okay, so it all depends what you have. So if we're using, in this case, the ratio test, you will go ahead and take this limit, call it L, and you have what we call an and an plus 1. An just stands for the terms of the sequence, which is the stuff next to the sigma, pretty much. Okay, we wrote that down, and then you have the an plus 1. If you had a minus 1 to the n, by the way, here, like an alternating term, you could also include that. And for the an, and an plus 1 is just the term after an, which computational purposes just means you're replacing all the n's with n plus 1. And then we took the ratio of those two, an plus 1 over an, and we got something along these lines. And we did a bunch of work to simplify. We took a limit, and because we wanted this to be less than 1, we set it to be less than 1 because we want it to be converge according to the ratio test, multiplied by 2, and we got my radius to be 2. Okay, so in our case, we have the radius is 2, and let me write the statement that we were working with a minute ago, which was x minus 4 is less than 2. So the inside here was set to be less than 2. And what I'm going to do next is as follows. I'm going to solve this inequality. So you have an absolute value that's less than a positive number, and we are allowed to write this as a compound inequality as x minus 4 is less than 2, but also at the same time it's greater than minus 2. This is two inequalities in one. And what I'm going to do now is I'm going to add 4 to both sides to isolate the x. So this would be 6, and this would be 2. So your interval of convergence is every number, it's going to include every number between 2 and 6, not inclusive. The thing we don't know, though, is whether your series converges at the exact endpoints at 2, at 6. We do not know that. Okay. So we're going to find that out by plugging each of these individually. So the actual, in terms of like the structure of this, how to find that interval convergence, it's about solving that inequality. And once you solve that inequality, you'll get your numbers. And whether you include or not the endpoints, that's where you have to plug these back in. So if you plug x equals 2 back in your series, you would get n times 2 minus 4 to the n over 2 to the n. 2 minus 4 inside that parentheses would be negative 2 to the n over 2 to the n. This would be negative 1 to the n times 2 to the n over 2 to the n. That's what your series would look like. Negative 2 is like saying negative 1 times 2 to the n. I know that sounds simple, but I'm using that property to split it up to write it like what I did right here. And the purpose of me doing that is so I can simplify and cancel these off, and then you just get n equals 1, n times minus 1 to the n. And you're going to ask yourself a question. You put your value of x in one of the endpoints, and you'll get a series. And you're going to go ahead and test the series whether it converges or diverges. It all depends what the series looks like and what test you're going to use, right? So if you go and look at this, for example, you can use the divergence test. And that would mean you take the limit as n goes to infinity of this, and this will not equal 0. Therefore, that series n minus 1 to the n diverges. It will not include the starter, the infinity there, well, 1 to infinity. That's all right, just save time. And therefore, when I'm looking at my interval of convergence, I am not going to include 2 because your series diverges there. And now we're going to go to 6. And then if you check x equals 6 and you plug that in, you would get, infinity n equals 1, n 6 minus 4 over 2 to the n to the n. You would get n equals 1, n 2 to the n over 2 to the n. These would cancel out. And this would diverge as well. With a divergence test, for example. All right, and yeah, so it diverges at both places. So your interval of convergence here would be everything between 2 and 6 and not inclusive. Let me clean this up. Just looks like I am including 2, but I'm not. So there you go. So just to summarize what we did, you find your radius of convergence first. And if that radius is a number like it was 2, then you have an inequality that you will go ahead and solve. X minus whatever number is less than whatever number you get. It's a compound inequality. So it's x minus 4 is less than 2, greater than negative 2. You solve for x, and then you have every number between the endpoints series converges, but you don't know what the endpoints hold for you, so you have to plug them back in into your series and solve. And then the way you do that, you plug them back in, and then you have a series that results, and then you just use your knowledge that you know of series here, okay? And that's how that works. Yeah, and often it is the case that you'll see that it converges for one endpoint, and then it diverges for the other. Here, it just was for both. Oh, and one last thing. If you did come up with your radius was infinity, let me write this down here. If your radius was infinity, then your interval converges is minus infinity to infinity. And if your radius is 0, then your interval converges is only one single point. Okay, call that point A. And that's where your series is centered at. So a power series looks something like this. So it's not really an interval, it's just a value. But anyways, this would be your interval convergence here in this case, and then right here in this one. Okay. All right, well, thank you for your time.